Good morning. The topic is error measurement in a transducer engineering subject. See, first we know concept of transducer. Okay, so in that transducer is used to convert the energy from some physical form into electrical form. I mean, physical form means our energy or our weight can be converted into either voltage or current, electrical form. Okay, so that the topic is here error in measurement. A measurement cannot be made without errors. So error is defined as the algebraic difference between the absolute value and the true value of the quantity. The absolute value and the true value. The difference is named as error. So mathematically the error is defined, represented by the letter E, which is equal to the A suffix T minus A suffix M. So A suffix T is the true value and A suffix M is the measured value. While measuring time, we noted that value is called as measured value and A suffix T is the true value or absolute value. Then, so generally error is defined the difference between those two. And relative error. So relative error means E suffix or relative error equal to absolute error by true value. Okay. So I mean A suffix T minus A suffix M. The difference between the absolute value minus measured value by true value or absolute value. So that is relative error. Then percentage of relative error means which is multiplied by 100. Then relative accuracy. See how to obtain the relative accuracy means it is equal to 1 minus A suffix T minus A suffix M by A suffix T. I mean 1 minus modulus of relative error. That is relative accuracy. Okay. Then percentage of relative accuracy means that the relative accuracy is multiplied by 100. Then from this we can measure the full scale reading. So from the full scale reading, we can measure the error, which is equal to the absolute value minus measured value by full scale reading. Next, limiting error. So the limiting error of the deviation from the specified value is known as limiting error. The limit of the deviations from the specified value is known as limiting error. So A suffix A equal to A suffix S plus or minus del into A. So this is the notation for obtaining the limiting error. Okay. So the limit of the deviation from the specified value. Limiting error is expressed by the letter A suffix A, which is equal to the A suffix S. I mean the limiting from the specified value A suffix S plus or minus del into A. The del represents the limiting value. See, for example, the magnitude of a resistor is 100 ohm with a limiting error of plus or minus 10 ohm. The del is a 10 plus or minus 10 ohm. So the magnitude of resistance will be A suffix A is equal to 100 plus or minus 10 ohm. So the answer is either 90 ohm or 110 ohm. Plus 10 means 110 ohm or minus 10 means 90 ohm. So, acceptable value is either 90 ohm or greater than or equal to 90 ohm and less than or equal to 110 ohm. Then next, relative or fractional limiting error. So, it is defined as the ratio of the error to specified magnitude of the quantity. It is represented as relative limiting error, which is expressed by epsilon suffix R, which is equal to the del A by AS, A suffix S. Okay. Then our error can be analyzed by few parameters. One is arithmetic mean and deviation, standard deviation, variance, median, and mode. Okay. See, first we know error. Error is the difference between the absolute value and the true value of the quantity. So that is error. So now arithmetic mean. How to obtain the arithmetic mean? So these are the parameters which is used to analyze the error. Okay. So arithmetic mean. Arithmetic mean is given by x bar equal to x1 plus x2 plus etc. up to xn by n. I mean n number of times we can measure the reading. How many times you measure it? So each and every time the measurement value, we add those measurement values by how many times you measure, that is n. So summation of a is equal to 1 to n x of a by n. Okay, so here arithmetic mean is expressed by letter x of x bar, then x1, x2 up to xn. So these are the readings or variants of or samples at particular time. Then n, total number of readings. Okay, then second one, deviation. Deviation, it is nothing but departure of the observed reading from the arithmetic mean of the group of readings. Okay, observed reading. So first time you measuring the value. So you noted that value is called as observed reading or observed value. Okay. So the departure of the observed reading from the arithmetic mean of the group of readings. So that is deviation. Okay. So now the deviation of the reading x1 be d1 and that of reading x2 be d2, etc. So here d1, see in a mathematically how to express means d1 is equal to x1 minus x bar. D2 means x2 minus x bar. Likewise, at nth reading. So, for d sub is n is equal to x sub is n minus x bar. Okay, so that is deviation. And average deviation. So, which is equal to the, so modulus of each deviation, modulus of d1 plus modulus of d2, etc. Modulus of dn, divide by n. Okay, so summation of modulus of d, so where d sub is a or use any notation. So the variable is starting from 1 to n divided by n. That is summation of a is equal to 1 to n, x of is a minus x bar by n. So that is average deviation. Then standard deviation. So standard deviation is the square root of the sum of individual deviations squared divided by number of readings. I mean the standard deviation is expressed by the letter sigma, which is equal to the square root of d1 square plus d2 squared, etc. dn squared by n. So this is standard deviation. And variance, just the square of the standard deviation. So that is variance. So square root is cancelled. So the variance is d1 square plus d2 square plus etc. dn squared by n. So that is variance. Then median, how to calculate the median value in this error analysis. So it indicates most probable value of the measured quantity when a set of readings are taken. So one set of readings you are taken. So in that, which values occur most probably. So for that, first we arrange the readings in either ascending order or descending order of the magnitude, and middle value of the set is taken as the median. Okay. So for example, you measuring the temperature of a bath. So it is noted by 10 observers. Okay. For particular time, the temperature is measured by the 10 observers. So the readings are 75.5 degrees Celsius, 73.7 degrees Celsius. So like that, the readings are mentioned. So now we can arrange these readings in either ascending order or descending order, and then we take the middle value. So here, after arranging these temperature values, the middle value is 75.5 degrees Celsius. Okay, 75.5 degrees Celsius. So this is the median. Okay, so the median is nothing but we can arrange the readings either in ascending or descending of whole set of values, and then the middle value is called as median. Then next one, mode. So mode, how to obtain the mode? So it occurs most frequently in a set of observations and around which other items of the set cluster. Group of readings we can measure. So in that, frequently which reading can be occurred. So that is called mode. So for example, temperature readings in degrees Celsius. Okay, 30 degree, 31 degree, 32 degree, likewise 37 degrees Celsius. Up to this, the temperature readings are noted. Okay, so in that, 30 degrees Celsius is occurred 9 times. 31 degrees Celsius is occurred 4 times. 32 degrees Celsius is occurred 15 times. 33 degrees Celsius is occurred 25 times. Okay, so in that, which reading is occurred high? Frequently, its reading is occurred means 33 degrees Celsius, because 33 degrees Celsius is occurred 25 times. Okay, so the mode is 33 degrees Celsius. This is the answer. So, one observer measuring one particular temperature at particular time, or limited range of time. So, in that, which reading is occur frequently. The same reading, okay, is occur frequently. So that is called as mode. Okay, so in this example, 33 degrees Celsius is occur 25 times. So the mode is, answer is 33 degrees Celsius. Okay, next one, error analysis, one kind of method is statistical method. So it is used to analyze the error while measuring time. Okay, so in this statistical method actually having two steps. One is multi-sample test and another one single sample test. Okay, so in this multi-sample test, so in this test, repeated measurements of a given quantity are done using different test conditions by employing different observers. So that is multi-sample test, different observers, different test conditions. Okay, so this is multi-sample. Single sample test means single measurement only done under identical conditions, excepting for time. Time is different, but observer and the test is single. Okay, so the statistical method use terms like arithmetic mean, deviation, median, mode, etc. So these are all already in error analysis we know. Okay, we seen. So the same thing we can using in a statistical method. Okay, but in a statistical method, two kind of way we can analyze the error, but the parameters are same: standard deviation, median, mode, variance, the same parameters, but it is analyzed by either single observer or multiple observer. Okay, so arithmetic mean and range, particular range, and deviation, standard deviation, and variance. So these are all the same concepts in a error measurement. Okay, so statistical method in a error analysis, by the nature of random errors, the uncertainty associated with any measurement, it cannot be predicted. Only the probable error can be specified. So solution for this, one is normal distribution of error and a normal or Gaussian curve of error and probable error analysis. So from this we can analyze the error and we can come to conclusion. So here multi-sample observations. So from this we gather the data and it is scattered about some central value. Okay, so how to analyze this? By using histogram. Okay, so for example, one particular length we can measure, we can take 50 readings. Okay. So for one observer note that reading, a single person take different 50 times. Otherwise, 50 different observers take that reading. Okay. So in that, out of 50, one reading is 89.7, and three readings are same value 89.8, and 10 readings are same value 89.9, 19 readings are 90, 12 readings are 90.1, 4 readings are 90.2, and only one reading is 90.3. Okay, so now we can plot this histogram, frequency distribution curve. So histogram is nothing but one particular sample is occur at how many times. So that is analyzed by histogram. Okay, so here 89.7. So from this histogram curve, we can observe 89.7. The reading is occur only one time. 89.8 is occur 3 times. 89.9, the reading is occur 10 times. 90 is occur 19 times. 19.1 is occur 12 times. So particular sample is occur how many times? So that is defined by histogram. Okay, and this is a normal or Gaussian curve of error analysis method by using this formula: h by square root of pi exponent of minus h squared by x squared. So this is analyzed for analyzing random errors. Okay, and odds and uncertainty. So the probability of occurrence is called as odds. I mean, odds is number of chance that a particular reading will occur, and odds can be calculated as probability occurrence, which is the formula is odds by odds plus 1. Okay. So these are all the things, error measurement in a transducer engineering concept. And we know already transducer is nothing but it converts energy from one form to another form, physical form into electrical form. So for example, tacho generator. Okay, so it converts the physical value speed into voltage. Okay, so this is tacho generator is act as a transducer. Okay, so normally transducers are classified into different ways. One is on the basis of transduction form used and either primary and secondary transducer, analog and digital transducer, passive and active transducers, and transducer and inverse transducer. So these are all the major classifications. Based on this, the transducers are classified. So based on the principle of transduction, the transducers are classified into resistive transducer, inductive transducer, and capacitive transducer, depending upon how they convert the input quantity into resistance, capacitance, or inductance. So based on that, the transducers are classified as either resistive transducer or inductive transducer or capacitive transducer. So resistive transducer, resistance of a length of metallic wire. So for example, potentiometer device or resistance strain gauge and photoconductive cell. So these are the examples of resistive transducers. And inductive transducer, in that inductance of a coil is calculated by the L is equal to N into d pi by dt. So which is measured by N squared mu naught mu r into A by E. Okay. So for example is for inductive transducer is the magnetic circuit transducer, reluctance pickup, and eddy current gauge. So these are the example of inductive transducers. And the capacitive transducer, the capacitance value is measured by from the capacitance between the two conductor blades. So the formula is epsilon naught into epsilon r into A by D. Okay, so the area and the thickness. So here example for capacitive transducer is capacitor microphone. Okay, and then primary transducer. So it is one form of energy is converted into another form in this by using this primary transducer. And in a secondary transducer, output from the primary transducer is converted subsequently into a usable output. Okay, so for the secondary transducer, the output is in a physical form. In a primary transducer, input is in a physical form, which is converted into electrical form, either voltage or current. But here in the secondary transducer, the output is in output of the primary transducer is input to the secondary transducer, so it is converted into usable output. Okay, and one more thing, passive transducer. So here first the input is measured from the measured medium, which is given to the passive transducer. So now the passive transducer generates the output which is given to this next stage. Okay. So in this active transducer, the same thing, output is measured from the measured medium. And if the transducer to be inactive, we are externally given to the power supply. So it generates the output which is given to this next stage. Okay. And the last one, transducer and inverse transducer. So generally, transducer is a device which converts the non-electrical quantity into electrical quantity, physical quantity into electrical quantity. But in this inverse transducer, it converts electrical quantity into non-electrical quantity. Okay, so this is the concept of the transducer. In that, error can be measured by, or error is analyzed by different parameters like arithmetic mean, deviation, standard deviation, variance, median, and mode. So by using those parameters, we can analyze the error in a transducer. Okay, and the transducers are classified with respect to these ways, and the principle of transduction, and either primary or secondary, analog or digital, passive or active, and transducer or inverse transducer. So this is the major classification. Okay, thank you.